Okay, we're going to be talking about solving limits analytically, and we're going to take a look at this first theorem on some basic limits. If b and c are real numbers and n is a positive integer, then the following properties are true. So the first property here, the most basic, we have the limit of a constant, which I'm just calling b, and up here in our theorem we said that b, right, is any real number. As the limit as x approaches c is equal to b. So just think of this as the limit of a constant as x approaches really any real number is equal to the constant. And then we're going to look at an example of the limit of x as x approaches c is just equal to c. And then the third one here, we've got the limit of x to the n as x approaches c is equal to c to the n. So let's take a look at some examples. Okay, in that theorem, in the first property, we had the limit of a constant. Now, I've got the function defined here as f of x is equal to 3. And it is written the limit of f of x as x approaches 4 is equal to 3. That's what I'm claiming. Now we're going to replace this f of x with 3. We have defined our function to be equal to 3. And so I've replaced the f of x with a 3, and now it's written the limit of our constant as x approaches 4 is equal to the constant. So if this were any number, for example 10, then this here would be 10 also. Okay? So we're referring to our theorem in that first property. Now by taking a look at the graph of the function f of x is equal to 3. So here's our graph, and it is passing through the y-axis here, as you can see, at 3. So we were approaching 4. Here's 4 on the x-axis, and what we want to do is go straight up, and our x-coordinate 4 is associated with the y-coordinate 3. Now the limit means that we're coming in from the left-hand side at 4, and we're coming in from the right-hand side at 4, and as we get closer and closer to 4, coming in from the left and from the right, our y values are both approaching 3. Now of course it's a constant here, so it doesn't really matter. Now if x were approaching, for example, 1, as you can still see, it would be 3, and of course if you picked any number on the x-axis, right, it still would be 3. Let's take a look at another example. Okay, in this one here we've defined f of x to equal x, and so I've written what is the limit of f of x as x approaches 4, and I claim that it's equal to 4. So we've got it written out, the limit of x as x approaches 4 is equal to 4. Now this is called just direct substitution, where we take 4 and we plug it directly into the function and we get 4 out. Let's take a look at the graph. So I'm going to find 4 on the x-axis, and that would be about right here. Now when I say I'm coming in from the left approaching 4, pick a point somewhere to the left of 4, go up, find the graph, which I need to move this down a little bit. Okay, I believe that's better. So we picked a point to the left of 4 on the x-axis. We go straight up, we find the y value. Now as you can see here, this is going to be less than 4 if we go straight across on the y-axis. This right here on the y-axis is 4. These blocks are in increments of 2, so this would be 2 and then 4. So as you can see, as I get closer and closer to 4 on the left, what's happening to my y value? It's getting closer and closer to 4. And then on the right hand side, we look at it from the right, and the same thing. So I'm following the graph down as I get closer and closer to 4 from the right hand side. Alright, let's look at the next example. Alright, as you can see, here's the function. You plug it in, plugging 0 in for x, and we get 0 out.